So biconditional statements on page 3. Okay. When a conditional statement and its converse, remember, converse means you take the hypothesis and switch it with the conclusion. Okay, if the original and the converse are both true, then we can write one single biconditional statement. Okay, a biconditional statement is a statement that contains the phrase if and only if. So example 1, if the last digit of an integer is 5 or 0, then it is divisible by 5. So let's write the converse of this statement. If an integer is divisible by 5, then its last digit is 5 or 0. This is the converse statement. We have the original statement and the converse statement. Are they both true? Yes. Both of these are true statements. The last digit of an integer is 5 or 0. Then it is divisible by 5. So think of like 1,000 ends in a 0, divisible by 5. 45 ends in a 5, divisible by 5. If we know it's divisible by 5, we know it must end in a 5 or 0. So now we're going to write the biconditional statement. Because these are both true, write the biconditional. Write biconditional down so you know which one this is. Because the original and the converse is true, we can write the biconditional, which states the last digit of an integer is 5 and 0. The last digit of an integer is 5 or 0 if and only if it is divisible by 5. That is the biconditional. Which statement does it look just like? We have 3 statements. 2 of them look very similar. What did you say? The first one. It looks just like the first one. What did I draw? I dropped the if. I replaced the then with if and only if. So you take your original statement, drop the if, replace the then with if and only if. That's the biconditional statement. Let's try number 2. If an angle is obtuse, then it measures more than 90 degrees and less than 180 degrees. So we're going to write the converse. So if an angle measures more than 90 degrees and less than 180 degrees, then it is obtuse. It's It's my converse statement. Is the converse and the original true? Yes. If an angle measures more than 90 and less than 180, it's defined as an obtuse. If I tell you an angle is obtuse, you know that its measures between 90 and 180. Both of these are true. Now I can write the biconditional. So I'm going to take the original, I'm going to drop the if, and I'm going to replace this with if and only if. An angle is obtuse if and only if it measures more than 90 degrees and less than 180 degrees. Okay. Third example. If a quadrilateral is a trapezoid, then it has only one pair of parallel sides. We have to write the converse to find out if the converse is true. If a quadrilateral has only one pair of parallel sides, then it is a trapezoid. Thank you. One of them is not here. Wait, no, never mind. They're both here. Sorry. I think. Yep. So we just went over quadrilaterals. Quadrilaterals are shapes with four sides. We know that a trapezoid, by definition, has one pair of parallel sides. So the original is true. Is the converse true? If I tell you a four-sided figure has one pair of parallel sides, does that make it a trapezoid? The answer is yes. That's by definition what a trapezoid is. These are both true. So Reese, what do I get to write? What statement do we write if the original conditional statement is true and the converse is true? Which one? Quincy. What? Skylar, what statement do I get to write? What are we learning about today? I get to write the biconditional statement. Because these are both true, I get to write the biconditional statement. Biconditional statement is same as the original, just drop the if, replace then with if and only if. So, a quadrilateral is a trapezoid if and only if it has only one pair of parallel sides. how does this relate to math? Let's write that at the top. How does this relate to math? So, in a number of mathematical textbooks, biconditionals are used to write theorems, postulates, and definitions. And detention, sorry. So what makes a good definition? Number one, a good definition is easy to understand. Number two, a good definition is precise. Number three, a good definition is biconditional. In a mathematical world, a definition has to be biconditional. You have to be able to write a biconditional statement for it to be true. So example 4, is it a good definition? A compass is a geometric tool. Okay, let's talk about why. Number one, is it easy to understand? Yes, everybody understands it. 2, is it precise? No. Is it biconditional? No. Biconditional means if I can read the converse statement and it's not true, it's not biconditional. For example, if something is a geometric tool, then it is a compass. That's not true. We have things called protractors, we have things called rulers. Those are not compasses. It's not true. It does not have a biconditional statement. So, no, it is not precise and or biconditional. Is this a good definition? Vertical angles are two angles whose sides are opposite rays. Okay, have I gone over what a vertical angle is? Vertical angles are basically created when two lines intersect. So these are vertical angles. So vertical angles are two angles whose sides are opposite rays. Okay. Is this a good definition? Is it easy to understand? Maybe for most of you. Okay. 2, is it precise? Yes, it tells us exactly each part. 3, is it biconditional? Why? Can you come up with a counter example? Correct. So if the definition doesn't say if and only if, that doesn't mean that it's not biconditional. Okay, so if I have a set of rays that are opposite rays, it will make vertical angles. That's the biconditional, basically. It's the converse statement, which is true, so it can be biconditional. So the answer is yes. It is easy to understand, comma, precise, and biconditional. Number 3. A ligament is a band of tough tissue connecting bones or holding organs in place. You guys take science class, is that true? Yes. It's easy to understand, precise, in biconditional. All right, now we're going to do 10.4K.